In this video, I will be talking about propagation of error. So let us say we have got a rod and we want to measure the length. Let us say its length is L. But if there is a inaccuracy in the measuring instrument, then actual length might be plus minus absolute error. Say for example, there is error delta L. So the actual length will be L plus minus delta L. Okay, because the instrument with which you are measuring that length is not very accurate. Okay, so there will be some error in the measurement. If the least count of the measuring instrument is say delta L, then the actual length will be actually it will be plus or minus of this delta L. So if there is a error in measuring some quantity, say length in this case, what happens is that if you are trying to use that particular measured quantity in some formulas, then that error is propagated. For example, let us say you want to calculate area of rectangle, and for that we need length and breadth, right? But if there is error in the length, or if there is error in breadth, or in both length and breadth, if there is error, then when you calculate the area of rectangle, that area of rectangle will also have an error, and that is called as propagation of error. Another example is say you want to calculate volume of the sphere, and to calculate the volume of the sphere, you need the radius, right? But when measuring the radius of that sphere, if you make a mistake, or if there is error in that measurement of the radius, then if you apply this formula and you calculate the volume, that volume itself will have some error. Okay, volume will also have error. What is the reason why volume will have error? Because the error in the measurement of radius has been propagated to the volume of the sphere as well. So that is the simple meaning of the propagation of error. And if you know the errors in the measurement of say radius, then you can calculate how much error will be in the volume of the sphere as well, in terms of percentage or fractional as well. So there are various techniques that people use to calculate the propagation in an error. There are some formulas that we can use. So here I'm going to explain a couple of formulas. Let us say you want to calculate area of rectangle. So formula is length into breadth. Since there is error in the length and breadth, then there will be error in the area of rectangle. So relative error in the area is written as this one. It can be calculated as delta L, absolute error in the length, and then L plus. So whenever there is multiplication sign, remember that we have to add these relative errors and delta B divided by B. So if there is error in this measurement of the breadth, then we can use that and then just add that relative error over here. That's it. That's how you can calculate the error in the area of rectangle. So this is the relative error, but if you want to calculate the fraction percentage error, you can just multiply by 100. So that will be percentage error. Same technique you can apply for the volume of the sphere as well. Say volume of the sphere is 4 by 3 pi r cube. And if you want to calculate the relative error, you can write it this way. And remember that whenever you are calculating the relative errors, we need to ignore this constant thing. So we have got 4 by 3 pi. So this is constant. So we have to ignore this. If you have formula something like this, say x is equal to y raised to n, then delta x by x is equal to n delta y by y. So you need to remember this formula. You can apply this formula to r cube. So here n is equal to 3. So it will become 3 delta r divided by r. So that will be the relative error in volume. If you know the relative error in the radius, then just multiply by 3 and you will get the relative error in volume. And if you want to find out the percentage error, just multiply by 100. Simple. 3 delta r by r into 100. So this is the percentage error in the radius. This is the percentage error in volume. Thank you for watching.